Okay, so we're going to continue with complex numbers. So we've worked all the way through number 4. I'm going to pick up and do multiplying when we have it already simplified, like the radicals are already simplified. We already have the i's, and we have the multiplication between the parentheses. That's true for both 5 and 6. Then we'll get into the dividing problems, number 7 and 8, and then we'll look at what to do when you have higher powers of I. Okay? All right, so let's go ahead and look at -4 minus 3i and then -2 plus 5i. So we're going to be multiplying. So we're going to wind up distributing the -4 throughout and then coming back and distributing the -3i throughout. So this is just like what you would do if you were foiling. You're treating it to start with just like you would if these were variables. So you're going to do, and I'm going to write a step here that normally you won't write. Normally you just think this. In fact, I'll write that. So you think, okay, -4 times -2. Okay, then you're going to do -4 times 5i. Then you're going to do -3i times -2. And then you're going to do -3i times 5i. But in reality, what I want you to do is just think that. Don't actually write that. Think negative times a negative is positive. 4 times 2 is 8. Negative times a positive is negative. 4 times 5 is 20. And you got an I on that one. Okay. And then think -3i times -2. Negative times a negative is positive. It would be positive 6 with an I on it. And then when you do the -3i times the positive 5i, you know it's minus. And then see how the -3 and the 5 would be -15, and then I times I would be I squared. So that is what I really want you writing as your first step. This should just be something you think about. All right, then at that point, we've got like terms here that we can combine, and then we have that issue. Remember, on multiplying, this comes up a lot. You need to remember when you see an I squared that it equals -1. So replace the I squared with -1. So you wind up having 8, -20i, and positive 6i would be -14i. -15 times -1 would be plus 15. And then these are like terms, the 8 and the 15. So your final answer would be 23 minus 14i on that one. So on this one, it's kind of nice because we didn't have to simplify the radicals to get the i's. They were already there. Same is true on number 6. So let's look at number 6. Okay. So on it, you had 3 minus 2i being multiplied by 3 plus 2i. So you'll FOIL that out. You'll do 3 times 3 and 3 times the 2i. So 3 times 3 is 9. Positive 3 times positive, that would be positive 6i. Then you'll come back and you'll do negative 2i times 3, which is minus 6i. And then negative 2i times positive 2i, which is minus 4i squared. So you got a couple things here. This is going to be replaced with a -1. Positive 6i and negative 6i, they're like terms, but they actually cancel out. They add up to be 0, don't they? So they're gone. And so you wind up with 9. -4 times -1, that would be plus 4. And 9 plus 4 is 13. This one turns out to just be the number 13 when you're finished. There's no i's left anywhere, because the middle terms were special, were opposites, so they canceled out, and then I squared got replaced, so -4 times -1 gave you just positive 4, and then 9 and 4 could be combined. We're going to use that result in a minute on number 8. Okay, all right, so that's the end of the multiplying problems. Now 7 and 8 are dividing. So on 7, we're taking 5 divided by 2i, and on 8, we're doing -3 divided by 4 minus I. Okay, so it says dividing, but sometimes it doesn't. Sometimes it'll say, sometimes it'll say divide, you might think. But a lot of times it'll say rationalize the denominator. See, what happens is when you have radicals in the bottom of a fraction, the denominator, it's not considered fully simplified. And you have to rationalize. You have to make that denominator be not a 2i, but some kind of nice number like a 5 or whatever it turns out to be. Okay, so here's how you do it. You utilize the fact that you know I squared equals -1. So on problem number 7, we're going to do this. We know we can multiply the top and the bottom of a fraction by the same number, and we don't change what the number really was. As long as we do the top and the bottom by the same thing, it's just a different version of what we have. So what we're going to do is we're going to multiply by I on this one. Then we get a 5i, and we get a 2i squared. And see, the I squared we recognize as being equal to -1. So we wind up with a 5i on top. And then in the denominator, we really just have -2. So this is just -5/2i. And it can be written -5i over 2. It can be left this way, it can be written that way, or it can be written that way. Okay? So if you just have a single term in the denominator that has an I in it, just multiplying by an I is going to turn that into something with an I squared, which can be replaced with -1. Now we kind of want that to happen here, but multiplying by I by itself doesn't work, because if you did, that I would have to get distributed to both, and it would just be like moving the problem from the end to the beginning, so it doesn't really fix it. So what we're going to do for this problem, this is number 8, is we're going to utilize the interesting thing that happened on number 6. Do you see how you had a 3 minus 2i and a 3 plus 2i, and you wound up with a really nice number? See that relationship? One positive, one negative. Everything else is the same. So we're going to wind up using that here. So we're going to multiply by 4 plus I. And if we do that in the denominator, it doesn't matter that much. Then we're going to do that in the numerator as well, because you have to multiply the top and the bottom by the same thing. Okay, now, what happens in the denominator? Let's do that first, because that's why we did what we did, is you would get 4 times 4, which is 16, 4 times I, which is 4i, negative I times 4, which is minus 4i, and then negative I times positive I would be negative I squared. Now let's keep going on that before I go back up to the numerator. So you see how the middle terms are the same, just one positive, one negative? Okay, so they're going to cancel out. And then see how this I squared we could replace with -1. So that denominator becomes 16, and we have minus a -1. Minus a -1 is plus 1. Okay, so it winds up being just 17 down there. That's why we did what we did, because we turned the denominator into a rational number. That's why it's called rationalize the denominator. Now, in the numerator, we could distribute that, and we'd get -12 minus 3i. So I'm just going to bring that down, because those aren't like terms. You can't combine them. And then normally I like my answers kind of left like that. When we're working with the quadratic formula, we get things that look like that. But when you have problems with i's in them, they sometimes ask for you to put in a plus bi form. So if it tells you to put it in a plus bi form, then you need to separate this into -12 over 17 and then minus 3 over 17i. Then this is like the a and this is like the b. Okay? So that separating step is not really that important. It's just kind of showing that this really is a complex number. It's in a plus bi form. So that, and I would have accepted this too as a final answer. Okay? So 7 and 8, where you're dividing complex numbers, you're actually going to need to rationalize the denominator. And these both already had the i's, but you might have a problem where you have to simplify the square roots first. All right, the last two problems I want to do are looking at higher powers of I. So on number 9, I'm going to leave a little space because I'm going to do something up there. We have I raised to the 23rd power. And then on number 10, we have I raised to the 66th power. Okay. So what you're going to do on this is you're going to kind of observe this pattern I'm going to show you. So remember how I was square root of -1. And then with I squared, we squared the square root of -1, so we just have -1 left. We squared both sides. We wound up with -1. Okay, if you have an I to the third, you're just throwing another I on that, aren't you? So it's like you multiplied both sides of the previous problem by I. So it should be -1 times I, which is -I. If you did an I to the fourth, you could think of it like, okay, well, I'm going to take that -I that I had and throw one more I on it, right? Let me write that out better. Those two, I think I can show you that better. So isn't I to the third I squared times I? And I squared is -1 times I. And then I to the fourth you could think of as, well, that's I to the third times I. I to the third we just did. -I times I. And that's -I squared. Right? And I squared, equals -1. And so I to the fourth turns out to be 1. You could also do I to the fourth by thinking about I squared times I squared. That would be I to the fourth. So that would be -1 times -1, which is 1. Okay. All right, so let me simplify this now. Let's just summarize it then. Okay. So we know I equals square root of -1. We know I squared equals -1. We know I to the third equals -I, and I to the fourth equals +1. If you go to I to the fifth, let's do it up here. If I go to I to the fifth, I would be taking I to the fourth times another I, and I to the fourth is just 1. So do you see how I'm back to I again? And if I go to I to the sixth, that would be I to the fourth times I squared. I to the fourth is 1. I squared is -1. See how I'm at -1? I'm back here. I'm equal to that. That's what's going to happen, is when you get to the things higher than to the fourth power, you're going to start rotating through these 4 all over again. So we're going to utilize this fact. And the one I like to utilize more than any is this I to the fourth. So I like to think about how I to the 23rd, I like to split it. See how that's really okay, let me say one more thing. So if I kept up this pattern, see how this would be to the first, to the second, to the third, to the fourth, to the fifth, to the sixth. I to the seventh should fall here. I to the eighth should fall there. Then I would start again. This would be I to the ninth, I to the 10th, I to the 11th. This would be I to the 12th, would fall here. Okay. And then the next time I would wind up here would be I to the 16th, another round of 4. So notice that if I can get the exponent on the I to be something that is a multiple of 4, then I know that's going to equal just 1, which is really nice. So see how I to the 20th would have been it, I to the 24th, etc. So what you do, the easiest thing to do is to look at that and say, okay, I to the 23rd is I to the 20th with 3 leftover I's. And I to the 20th would fall here because it's a multiple of 4. So it's like there's I to the 4th 5 times. This is I to the 4th raised to the 5th power. You don't have to do that, but that's what's going on. It's like I to the 4th times itself 5 times. And each of those I to the 4ths would equal 1. So that whole I to the 20th part, that's going to be 1. And then you have the I to the 3rd left. And I to the 3rd is equal to -1. Okay, I to the third is, equal to -I is what I should have said. So this is 1 times -I. And you always write your I with that little tail on it. So I would equal negative, not I to the 23rd would equal -I, once you simplified it. So you kind of look for multiples of 4, okay? And I think that works really well. Now, there's a way you can use division to help you with that. If you divide by 4, it goes in there 5 whole times. And see that remainder of 3? That tells you that I to the 23rd would equal I to the 3rd. Because the other part of it would have been a multiple of 4, and that would have been equal to 1. And then I to the 3rd equals -I, and then you're done. So if you took the 66, divided it by 4, it would go in there 16 times with a remainder of 2. You see that? Basically, what that's telling us is that, see that 64 right there? We can see that could be I to the 64 with 2 more i's, and that would have gotten me to the 66. And this is really 4 times 16. So it's like I have I to the 4th 16 times. And I to the 4th, we like that because it's just 1, and 1 to any power is 1. And so you really just have I squared. And I squared equals -1. So that's your final answer. Now, you really can say, I usually do just this right here. And then because the 64 is a multiple of 4, so I usually just do this. I think of it like this. And then because the 64 is a multiple of 4, this part is 1. And then I squared is -1. And so that's my answer. Okay. Basically, you can look at the remainder when you do that division. That tells you what this is equal to. So we really know I to the 66 is going to equal I to the 2nd, and I to the 2nd is -1, and you're done. Okay. All right, so there's some homework on that, so you'll get more practice. Don't forget, there's an example in there, a lot of times videos that you can watch, okay? So I'm going to stop this and get it posted.